So now we're going to look at what's called empirical probability. It's also known as relative frequency probability, but in this book we call it empirical. This is the probability of an event obtained when we do an experiment. So when we make a bunch of observations or we're given data, all right, either a table set or they describe, we observed this out of this many times, A occurred this many times out of my total set, all right? And so it's always, again, the division's the same, but the description, instead of trying to figure it out based on what we understand about the problem, we just figure it out based on what we see, all right? What's observed, what's given to us in the data. Example, instead of figuring out the coin based on the fact that I know 50% of the time the coin should come up heads or 50% of the time it should come up tails, suppose I did an experiment, all right? So experimental probability, that's what empirical probability is. All right, so I toss a coin 50 times. That's the total number of tries, total number of outcomes in the experiment. All right, I observed that 38 of the flips resulted in heads. All right, using just the experiment, not what we understand about coins, find the probability of flipping heads on the next flip. So again, this is just based on observation and experimentation. It's not based on how we understand how coins work. So this would just be, well, probability that I get heads based on my observation would be the number of heads over my total flips. And so 38 out of 50 would be the, so it's 19 out of 25 or 0.76 or 76%. And so this particular experiment didn't come out to 50%, and that's okay. Sometimes it doesn't. All right. Later on, we're going to talk about the law of large numbers, and that will basically say that if I keep flipping it, eventually it'll get closer and closer to 50%. But again, based on just this particular set of information, on the experiment, based on my experimental numbers, the probability of flipping heads would be 38 out of 50, which is 0.76. All right, the next example is a table example, and when we have a table example, because all we're given is the number, we don't know about anything else, and so this is always empirical, because it's just based on a set of information, data set. All right, so a table example. We have a group of adults where we split them into men, women, whether they smoked or whether they didn't smoke. All right, so again, here's my table. There were total of 112 men, 118 women for 230 people. 87 of them were smokers, 143 of them were non-smokers, and then how they land in each group, right? 50 men were non-smokers, 62 were, 93 women were non-smokers, 93 women were non-smokers, which means 25 were smokers. All right, so reading the table and coming up with the information. So if we pick one of these people at random, find the probability we picked a male, which would be a man. Probability, we picked a male. Well, it will be the frequency. There are 112 chances out of the total 230, right, which has the reduced fraction. That's 56 out of 115, or 0.487. So a little less than 50% chance. All right, probability that they were a smoker. Again, out of all the people, what's the chance they were a smoker? Well, 87 of them, right? My total, 87. Those are my men. Those are my smokers. So 87 of them were a smoker out of my 230, which that one doesn't reduce, so 0.378, the chance, 37.8% chance. What's the probability that the person was a woman and a non-smoker? So I want both of those things. So I look at my table, how many women were non-smokers? Well, that's this 93. 93 of the women were classified as non-smokers. So out of the total, 93 of the women were non-smokers out of our 230. And again, then you write that as that one doesn't reduce. Oops. Wrote the wrong one down for... Double check that. 93 divided by 230, 0.404. All right, about 40% of the group were women non-smokers. Or is always the one you've got to be careful of, as we talked about in the last video. Probability it was a man or a smoker. So probability a male or a smoker would be the probability they were a male plus the probability they smoked minus the probability they were both, right? Both a male and a smoker. All right, we already did the men. 112 out of the 230 were men. 87 out of the 230 were smokers. But we did have some overlap, right? If I look at the men, this is how we get the men. Out of the 112, 50 were non-smokers, 62 were smokers. Out of the smokers, out of the 87, 62 were men, 25. So again, it's that overlap. Even though it's not a Venn diagram, there was overlap. When I counted the men, I counted that 62. And when I counted the smokers, I counted that 62. I don't want to count the 62 male smokers twice. And so I've got to make sure we subtract that. 62 men that were smokers got counted in both of those groups. And so whenever there's overlap, and there's overlap in this case, I've got to remember to subtract. So 112 plus 87 minus 62 divided by 130 comes out to 137 out of 230. There's an alternative way you could do it. You could go through where I've got this circled and just count up, not the totals, but you'd count up the 50, the 62, and the 25. That should add up to 187 or 137. But your rule of thumb is always use the formula because it will always do the subtraction for you. And the decimal comes out 0.596. So almost 60% of them were men or smokers. Female or non-smoker. So same thing. Probability they were female or a non-smoker would be the probability they were female plus the probability they were not a smoker minus the probability they were both, because they were both people classified as women and non-smoker. So out of 230, we have how many women? So I'm going to erase this so I can look up. Alright, so now we're looking at women. There are 118 women and the non-smokers. And again, the 93 would be the overlap. So women, they were 118 out of 23. The non-smokers, total 143. 143 minus the 93 that were both women and smokers. Right? So again, you got to make sure you have to make sure to subtract so you don't count anybody twice. When you simplify that, it comes out to 168 out of 230, which is 0.730, so 73%. Again, the formula, females plus non-smokers minus both, they were female and non-smoker. If you there is an alternative way. If you just add up the non-smokers and the women, and you only add up the 93 one time. So the 50, the 93, and the 25, right? The 50, the 93, the 25 would be the non-smoker one. That should add up to the 168. Alright, but again, the best way to do it is use the formula. You're least likely to make an error if you use the formula. Alright, I'm going to stop there. The next example in the next video.